Alright, in this video we're going to be talking about how to solve quadratics using factoring. So our goal is to find the solutions, remember that's your roots, your zeros, your x-intercepts, by factoring instead of graphing. So what we're going to do is take whatever equation and polynomial we're given, factor it. After we find the factors, we're going to set those factors equal to 0. Now this says factor the left side. That is if the polynomial is on the left side. If it's on the right side, then you wouldn't do that. What do you put factor? But then we set each factor equal to 0. We solve for x for both factors, and then we write our final answer curly. It says braces, but I say brackets. They're really the same thing. All right, so let's do a few examples. So this first one is an example where you have an a that's 1. So we're looking for two numbers that multiply to be 3, add to be 4. If you're still using the x, that's fine. So two numbers that multiply to be 3, add to be 4, that would be 3 and 1. So our factors would be x plus 3, x plus 1. Don't forget that this equals 0. That's why we're setting both factors equal to 0. So now I can remove the parentheses and set each factor equal to 0 and solve. So now x equals -3 and x equals -1. So our solutions are -3, -1. Hopefully that seems simple enough. We're going to do one more of these type and then move on to another. Number 4, we're looking for two numbers that multiply to be -27 but add to be 6. Remember, because the last term is negative, one of them had to be negative. Two numbers that would work are +9 and -3. So we have our factors x plus 9, x minus 3 equals 0. When you have factors that it's just x plus a number or x minus a number, you can still solve it. You'll get the same answer. But also, if you know that your answer for like this one is just going to be the opposite, you can go ahead and skip that step. Of course, if you're not sure of how I just got those final answers, I subtracted 9 and added 3. So you can always show that work, but it's not necessary. Right, we're going to skip down to number 9 and then do number 10. So this one, we have two terms, so it's not a trinomial, so we can use GCF or difference of squares. In this case, 8 is not a perfect square, so difference of squares is out. This does have a GCF of x, so I can bring in x out. And remember, we're dividing when we factor out, so x squared divided by x will leave us with x. -8x divided by x would leave us with just -8. And then we do the same thing. Set both factors equal to 0. Oh, I don't think I wrote. No, I didn't. This is curly brackets. When you write these in curly brackets, write them at least to greatest. So then we have x equals 0, that wouldn't change, and x equals 8. So our solutions would be 0, 8. For number 10, I can divide a 3 out of both as well as an x. So that would leave us with just x plus 5. And then I would set both equal to 0 and solve. This one I know is going to be -5. This one I'm just going to go ahead and divide both by 3, but that's going to stay 0. Most of the time when you divide out an x, no matter if you have a constant with it, a coefficient with it or not, you'll still get 0. So your solutions would be -5 and 0. Moving on. Now we're going to do some others. Now we have two terms that are perfect squares in number 13. So that means my two factors would be x minus 8 and x plus 8. Remember, we're looking for what times what gives us x squared, what times what gives us 64, and then putting plus and minus. So if we set both factors equal to 0, we come out with a positive 8 and a negative 8. So when you write your solutions, you can write them one of two ways. How we've been doing it, negative 8, 8. Or if it's the exact same number, just plus and minus, you can write it like this. This is a plus minus symbol to show that they are both there. Either would be acceptable. Moving on to number 15. This one does have perfect squares. And our factors would be now 2x minus 9 and 2x plus 9. For these, because we have a number in front of x, you should solve it. But because they're going to be the same thing, you don't need to solve it twice. It will just be the opposite. So for this one, I would add 9 and divide both sides by 2. Leave this as a fraction. You can put it as a decimal if it's a nice fraction, so like this, 9 over 2 would be 4.5. But if it was something over 3 that wasn't easily simplified, leave that as a fraction. So that means this other one is going to be the opposite. You could solve it just to make sure. But when you're dealing with the difference of squares ones, you should get both positive and negative of the same number. We're going to do just ones. Yeah, I thought I wrote this down, but I don't think I did. That's okay. For, let's say, number 20. If you get something that looks like any of these where you don't have a 0, that means you have to solve this partially and get a 0. You need to move everything to one side. I will say it's easier if you put everything on the left if it's already there. So like in number 20, I already have like my x squared and everything over here, so I could just move everything to the left. Or like in 21, my x squared is already on the left, so I want to move it to where I have like a positive first term. If moving it would make me have a negative, that wouldn't really change anything. You just would have to divide out a negative later. So you could do it to the right. That wouldn't really be an issue. You just have to remember to divide out the negative. So for number 20, I would move the 4x to where another x term is. Move the 1 to where another constant term is. So the x squared would stay the same. This would be negative 14x. And this would be plus 48. And then you could go from there. So I'm going to do this one since I started it already. We're looking for two numbers that multiply to be 48, but add to be negative 14. This would have to both be negatives, since the 48 is positive and 14 is negative, and negative 8 and negative 6 would work. So we'd have x minus 8 and x minus 6. So our answers would be 8 and 6. So putting that in our curly brackets, we have 6 and 8 inside curly brackets. Now, to do some factoring when A is not 1, we're just going to do a couple of these examples. Starting with the first example. Here we are looking for, well, scratch that. If you look at all of these, you can divide out by 3. And then go from there. So we're looking for two numbers that multiply to be negative 4 but add to be 3. Two that would work are positive 4 and negative 1. Now you would keep bringing down your 3 and have factors x plus 4 and x minus 1. in a normal situation where the number on the outside of that GCF has an x term, you could set it equal to 0. But if I set 3 equal to 0, there's nothing to solve, and that doesn't work. So that is not going to have a 0 or solution answer. But these two are. So this would be -4, and this would be 1. So our solutions would be -4 and 1. For example 3, this one does not have a GCF. So I'm looking for two numbers that multiply to be -10 but add to be 3. +5 and -2 would work. So then we would go through and do the whole process. Rewrite this so that it's 4 terms. Make sure you still set it equal to 0. Factor out your GCF of both. Still set it equal to 0. Rewrite your factors. And then from there, you can set each factor equal to 0 and solve. So for this one, I'm going to actually solve it by subtracting 5 and dividing by 2. Anytime you have a number in front of x, you're going to end up with a fraction for this. So our solutions would be at -5½ or -2.5 and 1. Just gonna do one more of these types and then show you something else very briefly. For number 14, if I had something like this, you still need to get everything to the same side. So since moving the x squared over here would still make this a positive first term, I'm going to do that. Move everything to the left. So move your x squareds together and your constants together. Now when I do this, I'm just moving it to this side. I'm not actually subtracting it to anything. So this would give me 4x squared plus 7x minus 2 equals 0. And then I could go from there. So just to show you one more example like this does not have a GCF, so we're looking for two numbers that multiply to be -8, but add to be 7. I think I said that wrong. Multiply to be -8, add to be 7, so +8 and -1 would work. So 4x squared plus 8x minus 1x minus 2. And then GCF would be 4x, x plus 2, -1, x plus 2. Our factors would be 4x minus 1 and x plus 2. So then you could set both factors equal to 0. And the first one we would need to solve. So 1/4. And then the second one you could still solve, but it'll be -2. So our solutions would be -2 and 1/4. Last thing I want to show you on this is what happens if you're given like a graph and then have to find the roots and have to find the equation. So with this, the factors that we've been finding, those solutions, those are our x-intercepts. Remember, those are all interchangeable. So if you find your x-intercepts, you can find your solutions / help find your roots, factors, and then find your equation. So for this first one, we have x equals 2 and x equals, what is that, -4? Yeah. So just as when we solve the factors, they would be backwards, when we write them, they would also be backwards. So instead of -4, that would be x plus 4. Instead of +2, that would be x minus 2. And if you are not sure, you could set it equal to 0. So if I put x plus 4 equals 0 and I solve it, I should get, the same x-intercept. If you don't, then you put the wrong sign. Okay. Then from there, we would start multiplying. X times x, x times negative 2, 4 times x, and 4 times negative 2. And once we combine our like terms, we would have our final quadratic, x squared plus 2x minus 8. You could graph this one, and it should match the one we have graphed. You could graph these factor one, it's in factor form, and that should also match. We do one more of these just so you make sure you're good with this. Here, this does have 2 x-intercepts at 7 and 8. So since they're both positive on the graph, they will be x minus 7 and x minus 8. So then when we multiply those out, we have x squared minus 8x minus 7x plus 56. And then combine our like terms. We have y equals x squared minus 15x plus 56. If you wanted to check yourself with these, you could factor it back out and you should get the same factors. And then you can solve those factors and there should be the solutions on the graph. Everything is connected, so however you want to show that. Now you have time to go and practice. Let me know if you need my help or have any